Section 4.2 is about multiplying polynomials, which basically runs on two concepts. One, which we talked about in that section that's at the beginning of chapter 4, I guess sort of before chapter 4 starts, where there are all the different shortcuts for simplifying exponential expressions, where you can add the exponents together if you're multiplying two terms that have the same base. So we're going to need that, and then we're going to need the distributive property, which I guess that one is sort of older than the exponent rule, right? I mean, I guess that would show up earlier. But those are the two things that we need, really. And if you're comfortable with those, you can do this. And there's kind of a lead up to it here, because here, if you look at this first one, you go, that's just a distributive property. Technically, this is multiplying two polynomials, although most people think of 6 as being a monomial. Monomials are technically polynomials, but this one you would just do with the distributive property, right? You would say, well, if you distribute that 6, then you're going to have 6 times x squared minus 6 times 3x plus 6 times 4. And then you say, well, then that's 6x squared minus 18x plus 24. Yep, and that's that, right? That's just using the distributive property. This one, here it's using that exponential rule, where I guess if you want to put the things next to each other that you're going to combine, so let's see, we have the two constants, since this is all just multiplied, right? Even though it's one monomial multiplied by another monomial, and the parentheses are supposed to kind of differentiate where the monomials are, really it's all multiplication in here. So you can rewrite the order and say this is negative 2 times 5 to get the constants next to each other, times x squared times x, and then times y to the fourth. So if you just want to put all those that way, so then the things that you're going to simplify essentially are right next to each other. Then negative 2 times 5 is negative 10. Then x squared times x would be x to the third, since you have 2 plus 1. And then y times y to the fourth is y to the fifth, right? From 1 plus 4. So you get negative 10 x to the third, y to the fifth. Okay, next, this is another distributive property, but then after that, you've got to use that exponent rule. So you could distribute the 2d squared, which is exactly what we're going to do, right? So we'd have 2d squared times 4d cubed minus 2d squared times d squared, then plus 2d squared times 3d, and then plus 2d squared times 7, right? You just distribute the d squared through this long 4-term polynomial over here, and then you can simplify these individual terms because you can add the exponents together, right? It's expressions involving d as the base, so you can add the exponents. Well, 2 times 4 is 8, and then you have d squared times d cubed. You can add those together. That's going to be d to the fifth. Then minus 2 times d raised to the power of 2 plus 2, which is 4. Then plus 2 times 3, which is 6, times d raised to the power of 2 plus 1, which is 3. And then 2 times 7 is 14, so 14 d squared at the end. All right, number 4 is like number 3, except that it has two variables. So we're going to distribute that 3x to the fifth y. So equals 3x to the fifth y times 5x to the fifth minus 3x to the fifth y times 4xy squared, and then plus 3x to the fifth y times 3y. And then we'll just simplify what we can with these terms. So 3 times 5, that's 15. Then x to the fifth, another x to the fifth. You can add those together. That's going to be x to the 10th. And then we do have a y in here as well. So 15x to the 10th times y. And then minus, let's see, 3 times 4 is 12. Then x to the fifth, and then an x to the first. 5 plus 1 is 6, so we have x to the 6th. then y and y squared. So 1 plus 2 is 3. So that term ends up being minus 12x to the 6th y cubed. And then the last one, 3 times 3 is 9, so plus 9x to the 5th, and then y squared, because we've got a y to the first and a y to the first, right? So it looks like that's what we're going to get there. All right, now I think we can get into actual proper polynomials, because each of these had at least one monomial in it, right? 6 is a monomial. Both of those are 2d squared, 3x to the 5th y. But what if both expressions have two terms? Okay, there are a couple of different ways to do this. You could distribute one by, since these are called binomials, right? So if you think a monomial, that's one term, binomial is 2, trinomial is 3, but usually when people say polynomial, even though that's supposed to be all of them, they just mean more than one. But those are two binomials, right? So you could distribute one binomial through the other, either way, right? You could distribute the 5x minus 2 through the x plus 3, or you could distribute the x plus 3 through the 5x plus 2. So I guess our options here, you could use the distributive property, which would also be called multiplying horizontally. If you look in our book, you could multiply vertically. I think multiplying vertically is hard because it's hard to keep the signs right, but you could do it. So you could multiply vertically. It's not my personal favorite, but I could see where somebody would find it easier, even though I don't. I think that's a fair way to put it. Or, and this is what I would do, FOIL, where you multiply the first two terms, the outer terms, the inner terms, and the last terms. So that's what I'm going to do with this thing. So 5x times x for the first terms. Then for the outer terms, so plus 5x times 3, right? Because the outer would be the one all the way on the left and the one all the way on the right. Then the inner terms would be negative 2 and x, right? Because the 2 on the inside. And then the last terms, negative 2 times 3. So there's my first, outer, inner, and last. And then you can simplify those. And 5x times x is 5x squared. Then 5x times 3 is 15x. Then plus negative 2x. And then plus negative 6. Or 5x squared. Then we can simplify here because these are like terms. So we could combine these and say 15 plus negative 2 or 15 minus 2 is 13. So plus 13x and then plus a negative 6. Most people call that minus 6. All right, then let's see. The next one, you could do the same thing, and that's exactly what I would do. So first terms, 3x times 2x. The last terms would be a 3x and a negative 7y. So I guess the one thing to be careful of when you're foiling is just to make sure that if you have a minus in the middle of your binomial, that goes with the second term of the binomial. So like how here I have a negative 7y, and then the next step when I do the two inner terms, I'm going to have a negative 8y times 2x. And then for the two last terms, negative 8y times negative 7y. Right, so here it is again where it's first, outer, inner, last. And then 3x times 2x, 3 times 2 is 6, so we get 6x squared. And then I could write this as plus a negative 21xy, but I'm just going to write this as minus 21xy. And then here, I'm going to write this as minus 16xy. Even though the order of the variables, it shows up as y then x, it's a good idea to have a consistent order of variables because then that way if you have like terms, you can see it right away. So I always write the variables in alphabetical order. I think that's the one that most people would pick, right? Like if you have A's and B's and you have terms with A's and B's, then you put the A's first, then the B's, right? Here, X comes before Y in the alphabet, so I'm going to put the X first. So I'm really just kind of rewriting the second one and getting the X first, but I'm doing it so that way it's more obvious that these two terms can combine together. And then the last part, negative times a negative is a positive, so this is plus 56y squared, right? A times 7 will give you the 56, then y times y will give you the y squared. But you can combine here, so negative 21 minus 16 is minus 37. So this would be 6x squared minus 37xy plus 56y squared. All right, 7 is kind of interesting because it's got those fractions in there and it's not in standard form. I should point out that foiling will still work if it's not in standard form. It just looks weird, but it'll still work. I think we're going to be better off, though, if we put this thing in standard form first. So we just have to flip the order of the second binomial. All right, the first one's fine, but we're going to write this as 4x plus 1/3 times 2x plus 1/5. Right, now this is in standard form, and I think we can go from there. So let's see then. What we're going to do is we're still going to FOIL, right? But we're going to FOIL the green one over here. So 4x times 2x. Then for the outer, we'll have plus 4x times 1/5. For the inner, we'll have plus 1/3 times 2x. Then for the last terms, plus 1/3 times 1/5. So what does putting it in standard form do? If I said foiling would work anyway if we didn't do it, the thing that it'll do is it'll automatically put this in descending order. So it'll put your final answer into standard form, which helps because then if you have like terms to combine, they're going to be right next to each other. That's good, right? And they're easier to see when they're right next to each other. So that's basically the point. And you don't have to do it. Right? If you've got an eagle eye for where the like terms are, I guess if it wasn't in standard form, you could get away with just going ahead and foiling that way. But I think for most of us, it's easier when the like terms are right next to each other. All right, so 4x times 2x is going to be 8x squared. And then, let's see, that's a 4/5 x. And then a 2/3 x. And then 1/3 times 1/5 is 1/15. So these are both x terms that we can combine, but we have to get a common denominator. So it looks like the least common multiple of 3 and 5 is going to be 15. So if we multiply 4/5 by 3/3, multiply 2/3 by 5/5, that should do it. So we're going to have 8x squared plus 12/15, if you multiply by 3/3, 12/15 x, plus 10/15 x, which is what you get if you multiply by 5/5 here, and then plus 1/15. And then you can combine those two terms now because we've got the same denominator. We can add them together. So we're going to have 8x squared plus 22/15 x plus 1/15. There we go. Okay, then number 8, we can't FOIL. You can only FOIL when it's two binomials, right? So I guess I should put that in back up here. Oh, come on. There we go. So then this only works with two binomials. But it's pretty effective with two binomials, I think. So what do you do if you have a binomial and something else, like a binomial and a trinomial? Well, you've got to distribute one of them through the other pretty much, unless you want to do long, like the vertical multiplication where it looks like long multiplication when you multiply two big numbers together. You could do it like that, but I think it's easier to get the signs right if you distribute. So what I would do, and I guess it doesn't matter, I mean, you could distribute the binomial through the trinomial or vice versa. I'm going to distribute the binomial through the trinomial, I think. So I'm going to have 2x squared times 3x plus 5 minus 7x times 3x plus 5, and then minus 4 times 3x plus 5. And then from there, it's the distributive property. So distributing the 2x squared, we're going to get, let's see, 6x cubed plus 10x squared out of that first product right here. And then minus what you get when you distribute 7x. So 7x times 3x is 21x squared. And 7x times 5 is 35x. Then minus, let's see, if you distribute the 4, that'll be 12x plus 20. Right? 4 times 5, 4 times 3x. All right, distributing those negatives, we're going to have 6x cubed plus 10x squared minus 21x squared minus 35x, and then minus 12x minus 20. And we do have to combine terms, but the like terms end up next to each other. The 2x squareds are next to each other, the 2x's are next to each other. So we're going to have 6x cubed, and then 10 minus 21 is negative 11, so negative 11x squared. And then negative 35 minus 12 is negative 47, so minus 47x, and then minus 20. And that should get us where we need to go. So you got to distribute when you've got more than just two binomials. So here we had a binomial and a trinomial, we had to distribute. Here we have two trinomials, and we had to distribute there too. So that's what we're going to do. Just to be different, I'm going to distribute the second one through the first instead of doing the first one through the second again. Not that it matters. You could do it whichever way you want, but I'm going to distribute the 3x squared minus x minus 2 through this one and say this will be x squared times 3x squared minus x minus 2, and then minus 5x times 3x squared minus x minus 2, and then plus 1 times 3x squared minus x minus 2. And I kind of went this way because I knew I was going to get that 1 times this other polynomial. So this part down here, you don't really have to do anything, right? You're multiplying by 1. And if you wanted to distribute the other way, if you're used to just always, you distribute the first polynomial through the second no matter what, that's fine. It'll work, but I guess some of the intermediate steps will look different. But that's all right. And then if we're going to distribute, let's see, distributing the x squared, we'll get 3x to the 4th, then minus x cubed, right, because you have 1 plus 2, then minus 2x squared, and then minus, let's see, what you get when you distribute a 5x. So 5x times 3x squared would be 15x cubed. Then 5x times negative x is minus 5x squared. And then 5x times negative 2 is minus 10x. And then just, if you're multiplying by 1, this will just be plus 3x squared minus x minus 2, right? Multiplying by 1 doesn't change anything. We just have to distribute a negative here. So we're going to have 3x to the 4th minus x cubed minus 2x squared minus 15x cubed plus 5x squared, then plus 10x. So there's distributing the negative through those three terms. And then at the end, we got plus 3x squared minus x minus 2. All right, this might be one to kind of X out terms as you go. So there's only one term with next to the 4th in it. We'll get that one out of the way right off the bat. X cubed, there's a minus x cubed, then a minus 15x cubed. All right, minus 1 minus 15 is minus 16x cubed. So that's out and that's out. X squareds, we got 3 of them. We got a minus 2x squared, a plus 5x squared, and a plus 3x squared. Minus 2 plus 5 is 3, plus another 3 is 6. So this is going to be plus 6x squared. So that one, and that one. X's, we got 2 of those, 10x and then minus x, so that's a plus 9x. And then at the end, there's just going to be a minus 2. That's the only thing that's left. Done. All right. A little more intense with 2 trinomials. And as you can imagine, if you get bigger, if you have like 4 and 5 term polynomials, I guess the work that we have would be wider, right? We would still kind of end up doing the same things, but there'd be a lot of terms to keep track of. All right, number 10, this is kind of a different look. So what do you do with this? These are all binomials, but there aren't two of them. There are three of them. Well, order of operations would say that you got to multiply, and then you got to multiply again. So just do the multiplication going left to right. So I guess really multiplication commutes, so you could multiply in whatever order you wanted, but we'll just go left to right. So we're going to FOIL the first two, and then the third one will just be kind of tacked on here at the end, and then we'll have to distribute it. But a plus 3 times a minus 1, if we FOIL, we're going to have a squared, and then minus a for the outer terms, plus 3a for the inner terms, and then minus 3. And then that'll have to get multiplied by a plus 4. We can clean this up a little, since we have like terms that we can combine, and we can say, well, this is going to be a squared plus 2a minus 3 times a plus 4. And then we have to distribute, so I'm going to distribute the smaller one, I guess. I'm going to distribute the a plus 4 through this trinomial, and we'll have a squared times a plus 4 plus 2a times a plus 4, and then minus 3 times a plus 4. And then more distributive property. Distribute the a squared through the a plus 4, you get a cubed plus 4a squared. And then after that, distribute the 2a, you get 2a squared plus 8a, right? 2a times 4 will give you the 8a. And then minus, let's see, when you distribute that 3a plus 12. So I just have to, oops, that should be a bracket. That looks inconsistent. Get that parenthesis out of here. So we just have to distribute a negative and then combine terms, and we should be good to go. All right, so we've got a cubed plus, and we could actually combine these now, but I'll just combine them all in the same step. So 4a squared plus 2a squared, and then plus 8a minus 3a minus 12 from distributing the negative. A cubed, combining the a squareds, we get 6a squared from 4 plus 2. Then 8 minus 3 is 5, so we have plus 5a and then minus 12. And that looks like that should do it. So a little bit longer because we got 3 polynomials that we're multiplying, but it uses stuff that we've already done, right? We had to FOIL, and then we had to distribute the binomial through the trinomial, and then more distributive property, and then just combining terms together. All right, I guess I wouldn't say the back half, but like the back third maybe of this section is special products. You can memorize these, so like these things right here. You can memorize this if you want to, but you don't need them, because you would get them naturally from FOILing. And I think the way to handle these, like eventually you'll just recognize them and know what they are if you just keep FOILing all the time. And I guess this kind of feeds into what my sort of, I don't want to say philosophy, but maybe aesthetic is, which is that I think it's better to memorize fewer things. I think that leads to greater flexibility. At least that works for me. So like I don't have these memorized. I mean, I remember what they are just because I've seen them so many times that if I memorize them, it's kind of involuntary, you know? And I mean, this first one, really, you see that one all the time. So that one, like, it's like, I know what it is reflexively, but that's just because I've seen it so much. And eventually it just kind of got burned into my brain. I didn't consciously try to memorize it. And I think maybe that's the way to go, because if you try to memorize these, there are trouble spots like these things down here. Like these don't work because they're missing the middle terms, right? Because if you square like big A plus big B, you should have big A squared plus 2AB plus B squared. And a similar thing happens if you square big A minus big B. So there is that middle term that's in there unless one or both of those quantities are 0, then you wouldn't have it. But usually you do. So you can memorize these if you want, if it helps you to just remember a lot of individual rules that you can use. But that doesn't work for me personally. I think it's easier to memorize less stuff. So I would just FOIL all these things. and not, invoke these properties up here. Like I would just think, all right, we're multiplying two binomials, let's FOIL, and you'd have x squared from the two first terms, and then minus 8x from the outer terms, plus 8x from the inner terms, and then 8 times 8 is 64, so minus 64 from the last two. And then if you combine terms, the middle term is going to be a 0x, right? Because these are additive inverses. And you would just end up with x squared minus 64. And you can do this thing up here, and you can say, oh, well, that's x squared minus 8 squared. Sure, it is. But I think it's easier just to FOIL. Same thing here, and I guess really kind of with all of these. So like if we FOILed this one, we'd have 7x squared times another 7x squared. And then for the outer, we'd have plus 7x squared times 4. For the inner, we'd have negative 4 times 7x squared. And then for the last, we're going to have negative 4 times 4. And then 7x squared times 7x squared, well, 7 times 7 is 49. And then you can add the exponents, so that's 49x to the 2 plus 2, which is 4. And then the next one, we're just multiplying by 4. That's not so bad. It's 28x squared. And then we'd have plus negative 28x squared, right? And then plus negative 16. So again, middle terms are going to add out, right? 28x squared minus 28x squared. So we're going to be left with 49x to the 4th minus 16. Right? Plus a negative 16 would be the same thing as minus 16. And according to the formula up above, yeah, it's 7x squared, quantity squared, minus 4 squared. That does work. Then let's see, this one where it's a square. Okay, well, we could just write this as 5x plus 3y times another 5x plus 3y. And then just FOIL it. And that's what I would do with this thing. And say this is going to be 5x times another 5x. Plus, for the outer, 5x times 3y. And then for the inner, plus 3y times 5x. And then for the last, 3y times another 3y. All right, so 5x times 5x is 25x squared. Then here we're going to have a 15xy. The next term is also going to be 15xy if you rewrite the variable order so that they're in alphabetical order, right? Because they would naturally come out as y then x, but I flipped it so it'll match up and we can combine terms. And then plus 9y squared. And yeah, you could add these two together, and 15 plus 15 is 30. So you could write this as 25x squared plus 30xy plus 9y squared. And then it'll match up with what you get if you did use the formula on the last page. Similar idea here. I would just write this one out as 4x minus 2y cubed times another 4x minus 2y cubed. And just FOIL it. And I'd say, all right, well, then that's going to be 4x times 4x plus 4x times negative 2y cubed for the outer, plus negative 2y cubed times 4x for the inner, and then plus negative 2y cubed times negative 2y cubed. And then let's see, this will be 16x squared, then minus 8xy cubed, and then minus another 8xy cubed to rearrange the variable order, and then plus 4y to the 6th, right? Negative times a negative is a positive, so that's why it's a plus 4. And then you can add the exponents, and 3 plus 3 is going to be 6. So this will be 16x squared minus 16xy cubed if you combine those two middle terms, and then plus 4y to the 6th. All right, there is one other thing I want to point out here, which is you could factor a 2 out of this thing that's being squared. And sometimes that helps, right? So this, you could write this as, I guess I have to put this in brackets maybe. So if I factor a 2 out, I'd be left with 2x minus y cubed, and then this whole thing is being squared, right? And then you could write this as, well, I'm getting ahead of myself writing a 4. I should write that as 2 squared. So you could write it as 2 squared times 2x minus y cubed squared. And then the 2 squared is just a 4. And then squaring this thing is a little bit easier because the numbers are smaller. Granted, here it doesn't matter too much because 4 and 2 aren't that big to begin with. But hypothetically, like what if you had, just for argument's sake, what if you had this, where you had like, I don't know, 74x minus 37y cubed squared? It would be better to factor out the 37, right? Even though 37 squared, you probably need a calculator for it. Then that's only one big number instead of having to deal with a whole bunch. So there are cases where you can factor things out, and sometimes that is helpful. Even though it feels like that might create extra work, maybe here it would because these numbers are small to begin with. But when they're big numbers like this, I would factor out that 37. So just for future reference, like you can do that, even though that's not really a thing that shows up in this section. Where if you have a common factor, you could factor it out right at the beginning. Then the last one, which is a cube instead of a square, right? I mean, I guess that's the important difference with this one is that is b minus 3 cubed. All right, so what we're going to have to do is, I mean, we can just expand this and say it's b minus 3 times b minus 3 times b minus 3. And then just FOIL the first two, and then we'll have to distribute that b minus 3 in the end. That's probably going to be the best move. So if we FOIL those first two, we'd have b squared minus 3b for the outer, minus another 3b for the inner, and then plus 9 for the negative 3 times negative 3. Then that'll be multiplied by b minus 3. We can combine terms a little bit and say, well, that's b squared minus 6b plus 9 times b minus 3. And then distribute. I guess I'll distribute, I'll do the big one through the little one. I never do it like that. So you'd have b times b squared minus 6b plus 9, and then minus 3 times b squared minus 6b plus 9. And then if you distribute the b here, you'd have b cubed minus 6b squared plus 9b. And then minus what you get when you distribute that 3, which would be 3b squared minus 18b plus 27. And then distributing the negative, we're going to have b cubed minus 6b squared plus 9b minus 3b squared plus 18b minus 27. And then if we combine like terms, we're going to have b cubed. We have a couple of b squared, so minus 6 minus 3 is minus 9b squared. And then, let's see, I guess maybe this is one to do that, since they're not all next to each other. We got a 9b and an 18b, that's 27b. And then just minus 27 on the end. And that's that. Okay, so that takes care of what you do with a cube, right? You can still do the same things, just there's more to do, right? We had to FOIL and then we had to distribute. There actually is also a formula for this. Like generally for x plus y quantity cubed, you would have x cubed plus 3x squared y plus 3xy squared plus y cubed. But that formula we don't really need right now. I think just doing it the long way is probably helpful. And honestly, those cube formulas, I never actually remembered them. I just always derived them later. So I guess that goes back to where I said I try not to memorize a ton of stuff, and I think that helps. But anyway, I think that's about as long as they would get in this section. So I think that would cover everything in 4.2.